Hello everyone, my name is Dr. Michael Todd. I'm the Director of Laboratory Services in the Department of Pathology and Medical Laboratories at Wellstar Douglas Medical Center in Douglasville, Georgia. I also serve as the Chair of the Medical Laboratory Technician and Phlebotomy programs at Chattahoochee Technical College in the Atlanta, Georgia area. Been with Wellstar for the past 6 years, and I'd like to take you on a tour of our clinical chemistry department and give you a demonstration of loading patient samples on our new chemistry platform. This demonstration will be brought to you by our lead medical laboratory scientist in chemistry, Mrs. Lori Boynton. Mrs. Boynton brings over 40 years of experience at Wellstar Douglas alone. She is very excited to be here with you this evening and take you on this tour. Our clinical chemistry department is outfitted with not one, but two Roche Cobas Pro 8000 series clinical chemistry analyzers. These analyzers have a very high patient sample throughput. They are extremely easy to operate and also easy to maintain. Both of these analyzers were installed in February of 2025 after an upgrade from our previous Roche Cobas 6000 series analyzers. So let's sit back, relax, and let Ms. Lori Boynton introduce us to this new chemistry platform and also give you a broad overview and demonstration of how to load a patient sample on these analyzers.
Hey, I'm Lori Boynton and I'm running the chemistry department today. Each morning when we come in, we have to do all the calibration, QC, reagent loading of the instruments. And then we have daily, weekly, bi-weekly, monthly maintenance that we have to do, or we're like replacing probes and lamps and things like that. But basically this is 3 instruments put together. The first part here is the ISE. We've got ion selective electrodes in there that do sodium, potassium, and chloride on this part right here. And this is some of the bulk reagents. But the electrodes are actually inside of this module here. And it looks like a big instrument, but the reason why it's so big is because it's temperature controlled, because electrolytes are very temperature dependent. Some of the previous instruments that we had did not have that, and sometimes we'd have to recalibrate numerous times a day if the temperature fluctuated too much. The second instrument here is the Cobas 503. And it is general chemistries. All the chemistries that you're probably most familiar with, the glucose, BUN. We have 64 different tests that we're running on this analyzer right now. There's a reagent wheel on the inside. Everything comes pre-packaged if you want to. We no longer have to make each thing up ourselves. They already come made up. And then you just load them on the instrument. Okay. This is where the reagents are loaded. This big wheel here and these probes that you see, they're actually pipetting. They're like miniature test tubes. So everything that you're learning in class about the wavelength and what chemicals are mixed together, it's all robotics now versus doing it by hand. The next part here, this is the third instrument. This is the immunoassay instrument. We have reagents down there. A lot of this are cleaners because all of the main reagents are in the reagent cartridges. And we load those here. And immunoassays are the chemistries that are like CK&B, troponin, folate, B12, those kind of things. A lot of people find it very confusing, the difference between the general chemistries and the immunoassay. Technology is very different on the two.
Absolutely. And Ms. Laura, how long does it take for a sample to run depending on what's tested? How long would it take to get from one end of this analyzer to this end of the analyzer if we had a series of ISEs, general chemistries, and immunoassays down here?
ISEs take them like 2 minutes with this instrument, which is faster than some of the previous analyzers I've worked with. Okay. The general chemistries for a whole package, let's say like what we call a BNP, which is glucose, BUN, creatinine, electrolytes. Sometimes they add phosphorus, magnesium. That is going to take you 12 minutes. And then when it comes over here, it very depends on the test, because the troponin can be done in like 10 minutes, but a folate B12 takes 45 minutes.
Okay.
So it's very dependent on what test that you're running.
Okay. And how often do we need to do maintenance on these analyzers?
We do maintenance daily, which is not really hard to do the daily maintenance. You're mostly wiping the probes and restocking everything.
Okay.
The monthly maintenance, you take all of those wheels apart there and throw out all those plastic cuvettes and put new ones in. That's a change from the past where we had glass ones that you had to wash.
Okay. Excellent, excellent. And are there, since we have not only one, but we have two of these,
right? They're
are
mirror
we always
images.
running them in tandem, or are they just exact mirror images
They're
of
always
each
running
other?
unless one of them
Okay.
is broken.
Okay. Let's go take a look at the water system.
We have two water systems here, one for each instrument, and all of those jugs that you've seen on the instruments are concentrated, so they have to have water to run through and make dilutions, and that's what it cleans out between each reagent and each patient.
Okay.
The specimens from the nurse and staff or the phlebotomists at the front desk, and then they bring them and put them in our incoming rack here. So I take the specimen and I look at the label, make sure the barcode is looking okay, and then I read what test it is, because based on what the test is, it might actually go on a different analyzer than these. So once I have it, I select the correct rack for this type of specimen. We have urine racks, whole blood racks, and the red racks are for stats and the gray racks are for routines.
Okay.
So then I just pop the top, throw it in the trash, put it with the barcode facing out, and then it loads on the analyzer. And then to start the analyzer, I just flick the rack up. Everything's all good when the barcode is good, but if the barcode is messed up, then you'll have to manually program by going to order test, and then you'll have to like select the type of specimen, type in their specimen ID. Every specimen that comes to the lab has a unique ID. So if the barcode doesn't read, then we type in the ID, and then we can select whatever test that we need. But when the barcode's working, which then you don't have to do anything but wait on your results.
Okay.
If there's any kind of errors, you'll get like this yellow alarm.
Okay.
And the alarm, if you put it on, it didn't read the barcode. It could be that the specimen didn't get received at the front desk. Could be that the barcode's messed up. It could be that it's for a test that's not on our analyzer. Or it could be that the specimen was originally slated to go to one of our sister hospitals. Once it processes whatever test that it wants, then you have to look at the results. We have the results come across here, and when they're ready, it'll flag us, and then we look at it and decide whether the results are accurate, and then we let it go out to the patient's chart on the floor.
Excellent.
And we have a lot of like AI that helps us with that it does what we call delta checks. That's where it looks back on what the patient previously had, and if it's significantly different, then it'll flag that. We have critical values that'll stop if we have to stop and call either the RN or the doctor of the patient, and we have a very short time frame to get that done. There's just many different scenarios where maybe it doesn't think that it was in the linearity of the instrument, or the specimen has a problem that it might be hemolyzed, lipemic, and there's different processes we can do, or sometimes we have to have the specimen recollect.
Okay.
Then when we're done with the specimen, because so many of the patients have add-on tests, we have to file them with a computer so that it goes into these slots, and the computer knows exactly what slot it is. And then when the doctor places an add-on order, we'll get it in a request in the computer, and then we can come and just pluck out the specimen and use it again, so the patient doesn't have to have a venipuncture over and over.
Outstanding. Great. Thank you so much, Miss Lori. We definitely appreciate it.
Okay.
Welcome back, everyone. I sincerely hope that you enjoyed that tour of our clinical chemistry department and the demonstration of loading a patient sample on the Roche Cobas Pro 8000 series analyzers. As you can see, technology in the clinical chemistry department has come a very, very long way, and I hope that getting a glimpse of the type of technology that you will be exposed to in your clinical rotations and eventually in the workplace will further ignite your desire to pursue this career field and become the best that you can possibly be. Remember, the work that we do in the medical laboratory is extremely important, and without us, providers would simply be guessing. Thank you for joining me this evening. Thank you, Ms. Lori Boynton, for taking us on this tour, and I look forward to bringing you more videos like this in the very, very near future. Have a good day, everyone, and I look forward to seeing you soon. Take care.